Okay, I'll start recording and I'll start sharing my screen. And today we're going to look at more factoring trinomials. And I think I was just asking that homework 27 that's due by the end of the day, factoring. How is it? Does anybody want to look at any of those problems? No questions?
No.
All right, then what we're going to look at today is going to kind of ratchet up that idea of factoring trinomials a little bit more. If I take something like x plus 6 and I multiply it by something like x plus 2, when I multiply that out, finally I get x squared plus 2x plus 6x plus 12, or x squared plus 8x plus 12. And that was the multiplication side of things. And what we did last class was we said, okay, so if I start with that x squared plus 8x plus 12, and I want to factor it, it was pretty straightforward because over here, since I had x squared, I know that x squared can just be x times x. And so then over here, when I saw it was a positive 12, I said to multiply to be positive, the signs have to be the same. So they'd both be pluses. And then I'd look for numbers that multiply to 12, 1 times 12, 2 times 6, 3 times 4. And I said 2 times 6 and I didn't write it, I apologize. And we said, okay, which of those numbers would add to 8? And the 2 and 6 gave it to me, because we had said that if I had 1x squared, I'm looking for numbers that multiply to the constant and add to the middle. And I think we all kind of were able to wrap our minds around that, yes? Today it's going to get a little bit more involved because I want to look at, let's say I have 2x plus 3 times, let's say, 3x plus 4. And here, when I go through and I multiply this out, first would give me 6x squared, outer would give me plus 8x, inner would give me plus 9x, last would give me plus 12. So I've got that 6x squared plus 17x plus 12. And so if I were to factor, I'm looking for things that multiply to give me 6x squared. I'm looking for things that multiply to give me 12, but that's 17. How does that 17x fit in? It's not just the sum of the numbers. And so when I factor a general trinomial, one in which the leading coefficient is not 1, I have two options. I can use trial and error, and I would look at that trial and error if you're in a program where you have to go past Math 110 into the algebra and trig, into the pre-calculus, into the calculus, because while trial and error is more challenging to learn, once you learn it, there's less work in factoring. Or we can use what's called the AC method, which is very similar to our grouping. And so what's all of that about? Let's start by looking at some factoring problems. And let's start simple and work ourselves gradually harder. Let's say I want to ask you to factor 3x squared plus 8x plus 4. I think when we factored before, when we were looking at factoring trinomials with a leading coefficient of 1, we said that we wanted to first find factors of the first term. And so 3x squared, well, that's the only possibilities are 1x times 3x, which is what makes this one a simpler one because it's a prime number. Then the second thing that we said we wanted to do was we wanted to look for factors of the constant term or the last term. And so 4 could be 1 times 4, or it could be 2 times 2. Then I think the third thing we said that we were going to do is we were going to decide on our signs if the last term is positive, the signs are the same. And they're the same as that on the middle of, they're the same as the sign on the middle term. If the last one is negative, they're different, meaning that when I look at my binomials, one will have a plus sign and one will have a minus sign. I just rambled on for a long time with you folks about part of what we did when we started looking at factoring last week. Does this make sense so far? Any comments, questions, concerns? If not, because I've written so far down, I'm going to rewrite the question. We had 3x squared plus 8x plus 4. For 3x squared, we said it's going to be only 1 times 3x. For 4, we said it could be 1 times 4 or 2 times 2. When we're filling in our binomials, we know that our signs are going to be the same, both pluses. And now with guess and check, or trial and error, we know that for our first term, it can only be x and 3x. For the second term in each binomial, we have a choice. We're just guessing and checking. And please notice, to this point, I did not at all look at that middle term. I'm going to guess and check until I get something that boils out to give me that middle term. So we're going to guess and check, use trial and error until we have binomials that give us the middle, multiplied to the middle to give us the middle term. So, what do you want to try first? The 1 and 4 or the 2 and 2? Should we try the 1 and 4? If I put 1 here and 4 here, when I check, first 3x squared, outer plus 4x, inner plus 3x, last plus 4. And do you notice that gives me 7x? And I want 8x. So it's close, but no cigar. We can try the 1 and 4 again, putting the 4 in the other spot, the 1 in the other spot. First, 3x squared, outer plus 1x, inner plus 12x, last plus 4. Again, we know our first and last work, but you see here the middle gives us 13x. And so that doesn't check. So the 1 and 4 don't work. The other option is the 2 and 2. First, 3x squared, outer plus 2x, inner plus 6x, last plus 4. And you see this does give me the positive 8x in the middle. And so this would be my factored form. And what makes these more challenging is those first ones, we could look at the middle term and say, oh, it's got to add to that middle number. But please notice when we have a leading coefficient that's not 1, this is not the sum of those last things. That comes as the result of the outer and inner of FOIL. And so it makes it a little bit more challenging to find. Does everybody get what I'm saying?
Yes.
Yes. So trial and error, we're just looking at things that multiply to give us the first term, things that multiply to give us the last term, and we're going to multiply them out until we get it right. Instead, if I do it with the AC method, the AC method is called that because I'm looking at AX squared plus BX plus C. And so for the AC method, we're going to multiply A times C, or the leading coefficient, by the constant term. And again, this is going on the assumption that we're in descending order first. Then what we do is we look for factors of that product, A times C, that add to B. Then we're going to replace B with that sum. And factor by grouping. Am I scrolling up too fast, or are you guys all right?
All right.
So let's look at that same problem again this way. 3x squared plus 8x plus 4. That product, A times C, would be 3 times 4, which is 12. So now I want to look at factors of 12. 12 could be 1 times 12, could be 2 times 6, could be 3 times 4. I'm going to pick the ones that add to the middle term. So I'm going to pick the ones that add to 8. So instead of having 8x, we're going to replace the 8x with 2x plus 6x. And once we have that done, we're going to factor by grouping, which again, when I have 4 terms, I split it in half. The first two have a common factor of x, leaving me with 3x plus 2. The last two have a common factor of 2, leaving me with 3x plus 2. And so my factored form, one factor is 3x plus 2. And when I think of canceling out that factor, my other factor is x plus 2. So that's my final answer. And I want to scroll up and look at, do you notice when I did the trial and error, I got that same answer. Both methods will take us to the same place. And so I guess I want to ask you folks as a class, as we look at a lot more of factoring these general trinomials today, how much math do you need in the future? Are any of you going on to pre-calculus, calculus, and beyond? In which case you want to learn that trial and error. Or do you guys want to focus on the grouping instead, going on the assumption that you don't need as much math in the future? Or should we do each problem both ways? And you can weigh the pluses and minuses as we go through them. And no one's answering me. What do you guys think? Should we do them all both ways, or do you like the grouping better, or do you like the trial and error better, or, you know, where are we going?
I like the grouping.
All right. So let's look at another example. Let's look at 2x squared plus 13x plus 5. And first of all, if we're doing it by grouping, it's important that it's in descending order. So is everybody all right? My exponents are going down. That's good. So then the next thing I want to do is I want to take a times c, or the leading coefficient, times, oops, that 5 should be a 15. I apologize, I copied it wrong. Times the constant term. And so that gives me 30. Then I'm going to look for factors of 30 that add to 13. Well, my 30 can be 1 times 30, but that doesn't give me 13. Could be 2 times 15, but that doesn't add to 13. Could be 3 times 10. I think we have a winner. So I'm going to look at this as 2x squared plus 3x plus 10x, replacing the 13x with that sum that equals it, plus 15. Now grouping. The first two have an x in common. What would my other factor be after I common factor out that x? Anybody? Two x squared divided by x would be 2x. 3x divided by x would be 3. In the back, what would be a common factor between 10x and 15? Is there a number that goes into both 10 and 15?
5.
5, beautiful. When I divide out that 5, 10x divided by 5 would be 2x. 15 divided by 5 would be 3. Now, as I look at the big picture, does everybody see these match? I did something right. One factor is 2x plus 3. And then the other factor would be my x plus 5. And again, I would check by multiplying. First, 2x squared, outer, plus 10x, inner, plus 3x, last, plus 15. And that 10x plus 3x does give me the 13x that I want in the middle. And so I've got it. And that'll be my factor form. What do you think?
Good.
I do believe there might be some in the homework that ask you to just find the remaining factor. And I might have something like 8y squared minus 2y minus 55 equals, and they tell me that one of the factors is 2y plus 5, and I've got to figure out this other factor. Well, with this one, if I know one factor and I'm looking for the remaining, I would probably approach this one more with that trial and error mindset. But no, that some of my guessing has been taken care of already. You know how we usually look for something that multiplies us to give us 8y squared? Well, if we know that one factor is 2y, we don't have too much of a choice for this other factor, do we? Doesn't that other factor, in order to give me 8y squared, have to be 4y? So now we've got that first part filled in. Looking for the second number, it has to multiply to 55, the second in each binomial. If one's 5, do we have any choice as to what the other would be? Well, if one's 5, the other one has to be 11. And then knowing that it has to be negative tells me that my two signs have to be different. And so if the first one's a plus, the second one has to be a minus. And so you see, if we know one of the factors, it's usually easy to work backwards, looking again at the first and the last to find the other. But again, it's really important that we do our check. First is 8y squared. Outer would be minus 22y. Inner would be plus 20y. Last would be minus 55. And so do you see that while initially it doesn't look that like the 5 and 11 is going to give me a 2 in the middle, because of the way the signs behaved when I looked at my FOIL, that does give me the negative 2y in the middle. And so I've got it right. How's that one if there's one or two in the homework where they give you one of the two factors and you need to find the other one? We good? Not hearing anything. Let's just look at several more examples.
Actually, can we do another one of these examples?
Where you know one factor and you have to find the other?
Yeah.
Okay. Let's look at 6y squared plus 11y minus 10. One factor that we know is 2y plus 5, and we have to find the other factor. I'm going to shut up and ask you folks to find the missing factor. What would go in there? And I'm going to give you guys a couple minutes to figure that out, and then we'll go over it. Did anybody else get 3y minus 2?
Yes.
In order to get 6y squared, I'd have to multiply 2y by 3y. In order to get 10, I'd have to multiply 5 by 2. And in order to be negative, I know that I have to have different signs. And so that's where I get the 3y minus 2. Better?
A little.
Okay. Should we give it one more?
Yeah.
All right, one more. Let's look at 20x squared minus 7x minus 6 is equal to 5x plus 2 times some other binomial. And I'm asking you folks to find that missing factor for me. Did anybody else get 4x minus 3? Checking. Goes here to multiply to 20x squared. Multiplying my first gives me 20x squared. Outer, I'd have minus 15x. Inner, plus 8x. And then last, 2 times minus 3 would give me the minus 6. So I made sure that the first and last worked. And because we were already given one, do you see when I look at the outer and the inner, they do add to that negative 7x. And so we've got it. Better? And so if we know one of the factors, we're going to really just focus on multiplying to the first, multiplying to the last. And again, it's only when we do the outer and the inner, when we do the entire middle part, that we look at that middle term. But now let's look at something a little bit different. This time, let's look at factoring where we don't know one of the factors. And let's say I've got 2x squared minus 9x minus 5. For this one, would you folks rather use the trial and error or the grouping?
Grouping.
Grouping? Okay, for grouping then, we're in descending order. So when I look for AC, A is up. I apologize, my phone made a noise and it wasn't from them. A is 2. Here, C is negative 5. And so I'm looking for numbers that multiply to negative 10. And I want them to add to negative 9. And to multiply to negative 10, I could have negative 1 times 10, but those add to positive 9. I could have 1 times negative 10, and you see those add to negative 9. And so that's going to be my winning combination. So where I had a negative 9x, I can replace that with positive 1x minus 10x. And again, I'm not changing what it equals, just what it looks like. Now, when I go to do my grouping, the first two, 2x squared and 1x, what would you tell me is the common factor between them? What shows up in both of them?
Two.
Well, this one's got a 2, but I don't think 2 goes into 1. I think they both have an x though, don't they? So my common factor for these two guys is going to be that x. And again, to find that other factor, when I divide them by x, I'll be left with 2x plus 1. Now these two, 10 and 5, can both be divided by 5. But because this starts with a minus sign, remember we said that told us we were going to take out not just 5, but negative 5. And when I divide those both by negative 5, negative 10x divided by negative 5 would give me positive 2x. Negative 5 divided by negative 5 would give me positive 1. And when I get to that point, when I'm doing my factoring by grouping, the little kid in me starts smiling because I see that these guys are the same, so I did something right. My one factor is 2x plus 1. And then I almost think of just crossing those out to see what's left. And what's left would be the x minus 5. And so I'm thinking that that's my factor form. But again, whenever I factor, I'm going to check by FOILing. First, 2x squared, outer minus 10x, inner plus 1x, last minus 5. And when I look at those middle terms, minus 10x plus 1x would give me a negative 9x in the middle. Now I have to apologize. I forget what that original trinomial was. Was it 2x squared minus 9x minus 5? Yep. And so we did it. And this would be my factored form. Ready for some more?
Yep.
This time, let's mix things up a little bit and let's factor and let's take 6x squared minus 13xy plus 5y squared. Does anybody notice anything different about this one? Does anybody notice that we have two variables, x and y? We're starting with x squared. We're ending with y squared. Look at that middle term. It's got both of them, x times y. When I've got it starting with x squared, ending with y squared, and an xy in the middle, I know that the first terms will both have x's. I know that the second terms will both have y's. Now I'm looking here, my signs are the same, both minuses. And you see when I FOIL this out, first would be x squared, outer would be xy, inner would be xy, and so that gives me the xy. And so having that second variable in there just tells me, instead of just having a constant in the back, because it ends with y squared, they'll both have y's. But now to finish this one, 6x squared minus 13xy plus 5y squared. Am I correct in thinking that you folks want to again use your grouping? And so doing my grouping, again, I want to start with the product A times C. A times C would be 6 times 5, or 30. So now I want to find numbers that multiply to 30, but add to negative 13. Well, in order to add to negative 13 and multiply to positive 30, is everybody all right? They're both going to be negative numbers. So let's see, if I have negative 1 times negative 30, those definitely don't add to negative 13. They add to negative 31. If I take negative 2 times, let's see, 2 times 15 would give me 30. Those add to negative 17, which is not what I want. If I look at negative 3, let's see, 30 is 3 times 10. Negative 3 plus negative 10 is going to be negative 13, which is what I want. So that 13xy, that negative 13xy, pardon me, I'm going to think of it as minus 3xy minus 10xy. And then I've got my plus 5y squared. Is everybody all right? Because it's xy in the middle, I need xy on each of these. Now, when I do my grouping, let's see, 6 and 3 are both divisible by 3, and they both have an x in there. And when I think of taking 6x squared and dividing by 3x, I get 2x. When I think of taking negative 3xy and dividing it by positive 3x, don't I get negative y? Now, the last two, 10 and 5 are both divisible by 5. They both have a y. And again, if this middle one is negative, I'm going to use that negative 5y as my common factor. And so when I think of taking 10xy, negative 10xy, pardon me, and dividing it by negative 5y, negative 10 divided by negative 5 is 2. Xy divided by y is x. And then positive 5 divided by negative 5 is negative 1. Y squared divided by y is y. I did something right because they both have that 2x minus y in common. My other factor would be 3x minus 5y. And again, I want to do a check to make sure. First, 2x times 3x is 6x squared. Outer, 2x times negative 5y would be negative 10xy. Inner, negative y times 3x would be negative 3xy. Last, negative y times negative 5y, negative times negative is positive. 5y times y is y squared. So I'm starting with the 6x squared, which is what I want. I'm ending with the 5y squared, which is what I want. When I combine those middle terms, I get negative 13xy, which is what I want. And so we did it. What do you think?
Practice makes perfect.
Yes. Yes. Okay, I'm going to give you a challenging one here. Let's look at 2m squared plus 17m plus 10. And what we haven't been doing that we should, I apologize, is before I do anything, is there anything common to all the factors? And here I think that answer is no. And then I'm going on the assumption that you folks said you want to stick with that grouping method. And so A times C would be A is 2, C is 10, 2 times 10, or 20. So now we want to look for factors of 20 that have to add to 17. See, 20 is 1 times 20, but those add to 21. 20 is 2 times 10, but those add to 12. 20 is 4 times 5, but those add to 9. Anything else multiplied to 20? Can anybody think of any other factors of 20? And what happens is, because there are none, I'm not going to be able to do this by grouping. We'll say that it doesn't work. And so that's going to tell us that this is prime, or that it cannot be factored. And so when you go through and do these, the questions will give you a trinomial to factor, and they'll ask you, they'll given two choices. One choice is a dot, and you click on that and type in the factors. The other choice is a dot that says that the polynomial is prime. Doesn't happen often, but it will happen on occasion. And if it's prime, they're telling us that it cannot be factored. Another example. Let's look at 49p squared minus 7p minus 2. In this one, are there any common factors to all? Is there any numbers that go into 49, 7, and 2? I don't think so. So are we going to use that AC grouping method? Leading coefficient is 49. And that constant term, we're going to use that negative 2. And 49 times negative 2 gives me negative 98. And so we're looking for numbers that multiply to negative 98, that sum to negative 7. Well, multiply to negative 98, we can have 2 times negative 49, but those add to negative 47, so that doesn't work. We can have negative 2 times positive 49, but those add to positive 47, so that doesn't work. I think 7 goes into 98 14 times. And when I add 7 and negative 14, I get negative 7. And so this is our winner. So that negative 7, we're going to replace with positive 7p minus 14p minus 2. Then we're going to do our factoring by grouping. With our factoring by grouping, 49p squared and 7p have a common factor of 7p. When I divide 49p squared by 7p, I get 7p. When I divide 7p by itself, I get 1. Negative 14 and negative 2 have a common factor of negative 2. When I divide negative 14p times negative 2, I get positive 7p. Negative 2 divided by negative 2, anything divided by itself is 1. And so I've got this common factor of 7p plus 1. And our other factor is going to be that 7p minus 2. And until we're super confident in factoring, we want to check each time. First, 7p times 7p is 49p squared. Outer, 7p times negative 2. 7 times 2 is 14, and that's positive times negative is negative. Inner, 1 times 7p would be 7p. Last, 1 times negative 2 is negative 2. We've got our 49p squared, which we wanted. When we combine those middle terms, we have negative 7p. And then our last term is negative 2. And since that's what we started with, we've got it now. let's look at, let's have you folks do, 18x squared minus 9x minus 14. And I'm going to be quiet and have you folks try that one. How did you folks do? The numbers in that one were a little bit larger, and so it made it a little bit more challenging, but it's that same general idea. Multiply the first and the last and look for things that multiply to give you. You know, there's a lot of things that multiply to 252, and so we just kind of keep on grinding our way through until we get that -9 in the middle.
Yeah, that
Fun.
was helpful to factor it out like that. Thank you.
And when I go through and factor a number that large out, I start with the smallest things and kind of work my way up in order so that I don't miss anything. In between times, I thought to myself, no, 8 doesn't go in there, 10 doesn't go in there, 11 doesn't go in there, 5 doesn't go in there, and so on. I'm going to throw some new wrenches into the works. This time, let's look at 8a to the third plus 14a to the second plus 3a. And looking at that one, what do you notice that's different?
They all have the variable in common.
They all have the variable in front of it. We've got an a to the third, not an a squared. That's an odd exponent. But since they all have a variable, does it make sense that there's going to be a greatest common factor? And that greatest common factor is going to be my a. And so before I do my AC method, before I do my factoring by grouping, I'm going to factor out that a. And that'll leave me with, if I divide each of these by a, with 8a squared plus 4a plus 3. And so now this is where I'm going to try to factor. So looking at this, a little bit of trial and error, a little bit of grouping, because it's starting with a squared, they'll both be a's. Since it's positive, they'll be the same, both of them plus signs. And now when I look at my AC, 8 times 3 is 24. So I'm looking for factors of 24 that would add to 4. And now I'm just checking this and I'm wondering if I copied it wrong. No, I did copy it wrong. I apologize. That 4 should be a 14. I apologize. And so 24 is 1 times 24, but that adds to 25. 2 times 12, and that does add to 14. So I'm going to take that 8a squared plus 14, I'll replace with 14a, pardon me, I'll replace with 2a plus 12a plus 3. The first two have a 2a in common, and dividing by 2a, I'll be left with 4a plus 1. The last two are both divisible by positive 3, and dividing by positive 3, I'll still have that 4a plus 1. The one factor is that 4a plus 1. The other factor will be my remaining 2a plus 3. So that trinomial is 4a plus 1 times 2a plus 3. But we cannot lose our common factor. That common factor has to stay there. And so factored form, this one has 3 factors.
Just, can you refresh my memory how we get that 2a? How
This
you
one?
got, Down, next to last there.
This one?
No, just down, just
That-
above the factor. The 2A outside of the 4A plus 1. We divide,
Okay, what goes into both 8 and 8a squared and 2a squared? What's the greatest common factor? 8 and 2 are both even, so they have a factor of 2, and both of them have an a. And so that's the greatest common factor of those two terms.
okay, right, thank you.
And then over here, between the 12 and the 3, the
Yep.
greatest common factor would be 3. Okay,
Yep, thank you.
you're welcome. So let's try another one. Let's try negative x squared plus 2x plus 24. And what makes this one different is that when I'm in descending order, the leading term is negative. And factoring when the leading term is negative can be very difficult. The way we get around that is whenever the leading term is negative, we're going to first factor out a -1. In order to factor out that -1, I'm going to think of taking that entire trinomial and dividing each term by -1. So that'll give me x squared. Positive divided by negative is -2x. Positive divided by negative is -24. And then I'm going to have a common factor of -1. And now this trinomial doesn't look all that different. All of my signs have changed. But because that leading term is positive, it makes it much easier to factor. I'm never going to lose that -1 in front. But now, hey, wait a minute. This is one of those ones that we looked at last time. If the leading coefficient was 1, we know it's just going to be 1x times 1x. And so now we want to look for factors of -24 that add to -2. And -24, if I look at that as 24 being 4 times 6, +4 times -6 would give me that -2 in the middle. But if your leading term is negative, you're going to always want to start by factoring out that -1. Now, let's look at another one. Let's look at 5x squared minus 75x plus 60. And before I try to factor that trinomial, my head is hurting thinking about the AC method because 5 times 60 is rather huge. But then I'm looking at the 5, and I'm looking at the 60, and I'm looking at the 75, and I'm asking to myself, hey, wait a minute, 5, 75, and 60. Is there a common factor? Is there any number that goes into all three of them? Does anybody recognize that they're all divisible by 5? And so let's factor out that 5 before we begin. And again, to factor out that 5, I want to think of dividing each of them by 5. And that's going to leave me with x squared minus, what is that, 15x plus 60 divided by 5 is 12. And doesn't that look a lot easier to factor than my original problem?
Yep.
So now I'm looking for factors of 12 because 1 times 12 is 12. I'm looking for factors of 12 that add to 15. 1 and 12 would be 13. 2 and 6 would be 8. 3 and 4 would be 7. I don't think there are any numbers that multiply to 12 that would add to 15. And so this one only has a common factor. What if I have -4 plus 52x minus 48x squared? Does anybody notice that this one's not in order? So let's first put it in descending order. So that would start with the -48x squared plus the 52x minus the 4. Then we're starting with a negative. So we want to take out a negative common factor. Between 48, 52, and 4, I think that there's a common factor of 4, but because that leading one is negative, we're going to take out a common factor of -4. And so when I think of taking each of those terms and dividing them by -4, my common factor will be that -4, and I'll be left with 12x squared plus, no, I lied. 12x squared minus 13x plus 1. And now, when I look at that grouping method, that AC method, 12 times 1 gives me 12. And so I'm going to look for factors of 12 that add to not 13, but -13. Well, if I look at -1 times plus -12, pardon me, that gives me my -13. So I have -4 times, this would be 12x squared minus 1x minus 12x plus 1. The first two have x in common, leaving me with 12x minus 1. The second two don't have anything in common, but because I'm got that dangling negative sign out front, I'm going to take out a negative 1. And when I divide by negative 1, I'll have 12x minus 1. So my two sides share that 12x minus 1. My remaining factor is x minus 1. And then I don't want to lose that negative 4 out front. How fun is that?
Totally.
Totally. Yeah, I love it. So this idea of if you have a leading coefficient that's not 1, we're not going to just intrinsically look for numbers that add to the middle, but we've got to do that AC thing, look for factors of the product that add to the middle and do our grouping. Are we comfortable with this or no?
Can you say that what you just said again? We have, for the AC, we have to look for the product, which is,
Yeah,
Of the-
and then we have to look for factors of the product that add to the middle and do our factoring by grouping. I'm just looking at how much time we have left and what my agenda for the day is. And I am thinking that I'm going to backtrack a little bit. I am thinking that this homework 29, I'm going to put off. Homework 29, I'm going to put off until the 17th. And me saying it is not enough until I change it in the My Labs. So let me go through and do that real quick. And while I'm doing that real quick, I'm going to ask you folks to please factor. And I am going to give you, ooh, this is a fun one. 24a squared minus 6ab minus 30b squared. And I'm going to give you a hint. With this one, I think you might want to look for a common factor first. How'd I do?
Good.
How'd you guys do? We all right?
Yep.
Okay. Let's look at one more, and then it's a little early, but let's call it a day, because I could do these in front of you, with you, till we're all blue in the face. But I think in order to really master it, you've kind of just got to sit and grind them out on your own. So, everybody all right if we do one more and then call it a day? And I just saw one that I thought was really cool. And now there was a little bit different that we've done thus far. And now as I'm looking at this page full of them, I am wondering where it went. Oh no. Yeah, we'll do this one. Here it is. Let's say we have 20 s to the fourth plus 61 s to the third t plus 3 s squared t squared.
Is that 61?
That's 61. Nice big number. Did you want to try this one on your own, or shall we do it together?
Together, good.
Okay. First thing I'm going to ask, is there anything common? Is there anything that shows up in every single one of them? Number wise, I don't think so. How about variable wise? Is there a letter that shows up in all three of them?
Nope. Oh, yes, I'm sorry, S.
S. And what's the lowest exponent on S?
Squared.
So our common factor is S squared. So let's start by thinking of taking each of these and dividing them by S squared. That gives me 20 s squared plus 61 st plus 3 t squared. We've got that common factor out front of s squared. Now looking at my a times c, I'm going to take 20 times 3, which gives me 60. And what factors of 60 would add to 61? I'm thinking 60 times 1 is about it, right? So we've got s squared. That'll be 20 s squared plus 60. We're going to keep the variable part the same, s2, plus 1 s2 plus 3 t squared. Is everybody all right? Those first two have 20s in common. Dividing by 20s, I'd have s plus 3t. These last two have a positive t in common, and that would leave me with s plus 3t. So the common factor is s plus 3t. The other factor is 20s plus t. And I can't lose that s squared out in front. How fun is that?
That was good, thank you.
All right. So if we stop here, do you folks